students, after studying the open circuit PN junction, the next step is to know its electrical conduction properties. So this video will focus on applying an external voltage across the terminals of the PN junction in forward and reverse biasing. After this, I'll tell you the important concepts and frequently asked questions from the topic. So please watch the video completely and thoroughly, and do not forget to subscribe the channel for more contents. So let's start with the topic. Students, as you have seen in my previous video that how the PN junction behaves when the terminals anode and cathodes left open. Now in this video I will focus how the PN junction works when a voltage is applied across its anode and cathode terminals, that is the closed terminals case. The electrical conduction properties we are going to study. So it can be operated in forward bias or the reverse bias mode. What is the forward bias mode? It depends on the how the applied voltage terminus connected to the P and N materials. So let's start with the forward biasing. Before studying the forward biasing in detail, let's first quickly recall the important concepts of the open PN junction diode. So this is the P side and this one is the N side, and if there is no applied voltage, their terminals are left open, then what will happen when the P and N material come into the contact? The majority carriers of the P, that is the hose, will move from P to N due to the concentration gradient, and similarly the electrons, which are the majority carriers of the N materials, will move from N to P side, and this will constitute a current that is called the diffusion current. And because of the movement of the majority carriers, a depletion region is formed just at the junction. This depletion region is depleted of the free carriers. It constitutes only the immobile ions, that is the acceptor ion and the donor ions. Because of these charges, the electric field is established across the depletion region, and its direction is from N to P side, and this electric field motivates the minority carriers of N and P materials to move in presence of the electric field, and the minority carrier movement constitute the drift current. So these are the two currents. Now let's see how the applied voltage make a difference in the operation of the PN junction. So when a voltage VF is applied across the PN junction diode, the P side is connected to the positive of the voltage and N side is connected to the negative. It is called forward biasing. So P is connected to positive terminal and N to the negative terminal. It is very easy to remember this. So this is the forward biasing, and this forward bias VF voltage is in the direction that subtract from the V0. What is the V0? V0 is the barrier voltage at the equilibrium or the open terminal case. So resulting in a reduced barrier voltage. You can see this V0 minus VF is the effective barrier voltage in forward biasing. It will enable more hose to move from P to N side, and similarly electrons from N to P side, which means that the diffusion current will increase substantially. This will also affect the width and the charge of the depletion region. How it will affect? Will the forward biasing increase or decrease the width and charge of the depletion region? What do you say? It will reduce the width of the depletion region and so the charge. And of course there is a minority carrier movement which causes the drift current, but the value of this drift current is very small, or you can say negligible, in the forward biasing. So now the current at the external circuit will be ID minus IS, or you can say it is approximately equals to the diffusion current. So in the case of the forward biasing, the diffusion current is dominating over the drift current. Now next case is the reverse biasing of the PN junction diode. So in the reverse biasing, the P terminal is connected to the negative and N terminal is connected to the positive of the external applied voltage, that is the VR. So P is connected to negative and N is connected to the positive, just reverse. So this externally applied reverse bias voltage gets added to the barrier voltage at the equilibrium, So this is the effective barrier voltage at the reverse biasing, which affect the movement of the holes from P to N side and electrons from N to P side. Here the barrier voltage is increased. So if barrier voltage is increasing, then it will demotivate the movement of the majority carriers and decreases the diffusion current, while it favors the minority carrier movement. Why so? Because the width and charge will get increase in reverse bias mode. Here the increase of the charge will favor the minority carrier movement from N to P side. So in the case of the reverse biasing, the current in external circuit is given by approximately minus of IES. Now let's see the important concepts of the topic. For the case of forward biasing, the P terminal is connected to the positive of the applied voltage and N to the negative of the applied voltage. So this will increase the diffusion current, and the external circuit current is approximately equals to the diffusion current because the IES is very small, or you can say negligible. And how does this happen in the forward biasing? Forward biasing reduces the effective barrier voltage, and so the depletion region width and charge both will get reduced. Now in the reverse biasing case, the P side is connected to the negative terminal of the applied voltage, while the N side is connected to the positive terminal of the voltage. And in the case of the reverse biasing, the drift current dominates, and drift current is due to the minority carrier movement. So the current at the external circuit is almost equals to the minus of IES because the diffusion current is negligible in case of reverse biasing. Why so? Because in the reverse biasing, the effective barrier voltage increases, and this will also affect the width, and so the charge or the depletion region both will get increased. Now let's see frequently asked questions from the topic. So the first one is, in the PN junction diode, how the forward biasing increases the diffusion current substantially. The next one is, barrier voltage increases in reverse biased PN junction diode. Is it true or false? The next one, in what circumstances the minority carriers contribute majorly in the total current of a PN junction? And the last one is, what changes will you expect in the process of current conduction of a closed circuit PN junction if P side is heavily doped than N side? So think about it and reply me in the comment section. Students, this video is about the biasing of the PN junction diode. In the next video, you will see how the current and voltage of the PN junction diode is related and what is the saturation current. I hope you like this video, so please subscribe the channel for more contents and share it. If you have any queries regarding analog electronic circuit, digital electronics, VLSI design, VLSI EDA tools, microprocessors, microcontrollers, you can write me in the comment section or mail me. My mail ID is given in the description of the video. Thank you so much and have a nice day.